Hello everyone. Today we will going to see some practice questions from the chapter Classification and Periodicity of Elements. This is part 2. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So this is the index slides. We will going to see the practice questions from question number 9 to question number 16. Let's start with the question number 9. The ionic radii in angstrom of N3 negative, O2 negative and F negative, which is basically nitrogen 3 negative, oxygen 2 negative and fluorine negative respectively are. So we have given some values and we have to tell the ionic radii in angstrom of these three ions. Options are 1.36, 1.40 and 1.71. 1.71, 1.40 and 1.36. 1.40, 1.36 and 1.71, or 1.71, 1.36 and 1.40. You have 10 seconds to solve this question. After that, we will see the answer. Okay. Let's see the correct answer. So the correct answer is option B, that is 1.71, 1.40 and 1.36 are the ionic radii for these three ions given in the question. So the nitrogen 3 negative, oxygen 2 negative and fluorine negative are isoelectronic species with 10 electrons. What is mean by isoelectronic species? Basically the species having same number of electrons is known as isoelectronic species. Okay, so in the three of them, they all have the 10 electrons in it. Nitrogen is having 7 electrons, but as it has a charge of 3 negative, that means it has gained 3 electrons. So 7 plus 3 is 10. Oxygen is having 8 atomic number, that means 8 electrons are present in the oxygen. And 2 negative charges present on the oxygen, that is 2 electrons it has gained, that means 8 plus 2 is 10. And fluorine is having 9 electrons initially, but it is having negative charge also, so that means it gained 1 electron, so 9 plus 1 is 10. So all three of them have 10 electrons with them. So for isoelectronic species, this is the observation that the ionic radii is inversely related to the nuclear charge on the ion, on the species. Okay, so basically we can relate the ionic radii and the nuclear charge, and we have given the values. We just have to find out the correct one for the correct species, right? So the correct order of their radii would be the nitrogen having 3 negative charge should be having largest ionic radii because it is having the lowest charge, 3 negative, right? So lowest charge, highest ionic radii. So 1.71 is the ionic radii for the nitrogen 3 negative. Then for the oxygen 2 negative, the radii will be 1.40, and the fluorine negative, the radii will be 1.36. Okay, so higher the charge, lower the ionic radii, or lower the charge, higher the ionic radii. On the basis of this observation or this relation, we have concluded that the ionic radii for N3 negative, O2 negative and F negative are 1.71, 1.40 and 1.36 respectively. Thus your B option is the correct answer. Okay, let's move to the next question. Question number 10. The increasing order of ionic radii of the given isoelectronic species is. So in the options you can see we have given some isoelectronic species order in the increasing manner. We have to find out the correct order of the ionic radii for these species. Options are S2 negative having the highest ionic radii, then potassium positive, then calcium 2 positive, then chlorine negative. Potassium positive, calcium 2 positive, chlorine negative, sulfur 2 negative. Sulfur 2 negative most, then chlorine negative, then K positive, then calcium 2 positive. Or chlorine negative most, then calcium 2 positive, then S2 negative, then potassium positive. You have to choose the correct one, and you have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The correct answer is option C. That is, this is the increasing correct order from the given options of isoelectronic species. So, for isoelectronic species, the radius of the species is inversely related to the Z. Z is basically the atomic number representation. And if you see the species given in the options, it is chlorine negative, calcium 2 positive, potassium positive, and sulfur 2 negative, right? And if you write the atomic number for these species, for chlorine it will be 17, for calcium it will be 20, for potassium it will be 19, and for sulfur it will be 16. Right, but after seeing the charges present on these species, if you want to find out the electrons, chlorine having 17 electron, atomic number is equals to the number of electron present in that particular species or ions or atom. So as chlorine negative is having atomic number 17, that means chlorine having 17 number of electrons, but it has a negative charge. That means it is gained 1 electron. So 17 plus 1 will be 18. Calcium 2 positive. So for the calcium, the atomic number is 20, but 2 positive charge is present. That means it has lost the 2 electrons from it. So 20 minus 2 will be 18. In the case of potassium positive, potassium is having atomic number 19, so 19 electrons, but positive charge is present. That means 1 electron is lost by the potassium. That means that 19 minus 1 is equals to 18 electrons. And sulfur atomic number is 16, but it is having 2 negative charge on it. That means it has gained 2 electrons. So 16 plus 2 is 18. So that's why this is isoelectronic species. And if we write the order or ionic size order for these species given, it will be this, that the highest for the S2 negative, because lowest atomic number, highest radius. Okay, so you can see that lowest atomic number is of sulfur 2 negative. So the highest ionic size or ionic radius of sulfur will be, so sulfur 2 negative having the highest ionic radii, then chlorine negative, then potassium positive, and then calcium 2 positive. So this is the correct increasing order for the ionic radii of the given species, and thus the C option is the correct answer. Okay, let's move to the next question. Question number 11. The correct sequence which shows decreasing order of ionic radii of elements is. We have given some orders. We have to select the correct sequence of the decreasing order of ionic radii of these species. So options are the most ionic radii, the most highest ionic radii is for aluminium 3 positive, then Mg2 positive, then sodium positive, then fluorine negative, then oxygen 2 negative. Or sodium positive, then magnesium 2 positive, then aluminium 3 positive, then oxygen 2 negative, then fluorine negative. Or sodium positive, then fluorine negative, then magnesium 2 positive, then oxygen 2 negative, then aluminium 3 positive. Or oxygen 2 negative, then fluorine negative, then sodium positive, then magnesium 2 positive, then aluminium 3 positive. So you have to choose the correct sequence of the ionic radii given from the options. You have 10 seconds to solve this question. After that, we will see the correct answer. Let's see. The correct answer is option D. So oxygen 2 negative, fluorine negative, sodium positive, magnesium 2 positive, and aluminium 3 positive are isoelectronic species. If you count the electrons, it will be same in all of them. And higher the nuclear charge, smaller the radii of isoelectronic species. This is the relation we have studied in the previous questions also, that for isoelectronic species, the nuclear charge and the radii is inversely related. Right. So one is higher, other will be automatically lower. So ionic radii order will be this, that the most is for 2 negative, oxygen 2 negative, then fluorine negative, then sodium positive, then magnesium 2 positive, then lowest is for aluminium 3 positive. As you can see, higher the charge is, lowest will be there ionic radii, as aluminium 3 positive has the highest charge in the positive, right? So that means its ionic radii will be smallest from the given species, and thus the D option is the correct answer. Okay, let's move to the next one, that is question number 12. Which of the following properties shows a clear periodic variation along a group? So we have to tell that we have given the option in the options, we have given some properties. We have to find one property which show the periodic verification along a group. So if you see the periodic table of elements, you can see that the group is from top to bottom, and the period is from left to right. If you see in a periodic table, right? So in a group, along a group, a clear periodic variation will be of which property? Okay, so we have to select the correct one from the options. You have 10 seconds. Okay, options are first ionization energy, molar mass of element, number of isotopes of the atom, or all of above. Which property is clear periodic variation along a group? You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. Okay, the correct answer is option A, that is first ionization energy. So first ionization energy shows a clear periodic verification. First ionization energy show a clear periodic variation along a group. If you see in a group from top to bottom, it decreases down the group. Okay, basically first ionization energy is the energy we required for the losing of one single electrons from the outermost shell of the atom, right? So the first ionization energy decreases down the group, it is mentioned here, and that's why it is the property which shows a clear periodic variation along a group. And this is the question. Thus, our A option is the correct answer, that is first ionization energy. Okay, let's move to the next question. Question number 13. Which of the following atoms has the highest first ionization energy? We have to select the atom from the options having the highest first ionization energy from the other options. Okay, so options are sodium, potassium, scandium, or rubidium. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The correct answer is option C, that is scandium. As all the given elements belong to first group except scandium. So if you see sodium, potassium, and rubidium, all these three elements is belonging to the first group. Okay, excepting scandium, which is from the third or fourth group. So their ionization energy decreases down the group. Okay, so in a group, ionization energy decreases. So if sodium, potassium, and rubidium belongs to a same group, that means this will be the order between these three elements for the ionization energy. right? As ionization energy decreases down the group. So lowest will be for rubidium, then for potassium, and then highest is for sodium in a first group elements, right? But scandium is not belonging to the first group. And this order of sodium, potassium, and rubidium is due to poor shielding effect. The removal of one electron from the 4s orbital is difficult as compared to the 3s orbital. That's why this is the order between these three elements. And scandium, as it is belonging to a different group, and it is belonging to a transition element group also, right? So that's why it is having the highest first ionization energy as compared to these three others given elements. Okay, so from the options, the correct answer is option C, that is scandium, having the highest first ionization energy. Okay, let's move to the next question. Question number 14. Generally, the first ionization energy increases along a period. So, it is observed that the first ionization energy generally increases along a period. But there are some exceptions. Okay, in this case, one which is not an exception is we have to select the one option in which the exception is not present. Basically, that means that in which the first ionization energy is increasing along a period. Okay, we have to select that option. So options are nitrogen and oxygen, sodium and magnesium and aluminium, or beryllium and boron. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The correct answer is option B, that is sodium and magnesium. So if you see the sodium and magnesium, it is belonging to the second group and first and second group. Okay, second period and first and second group. Like sodium and magnesium, if you see the periodic table, it is on the same period. Okay, period is from left to right. So sodium and magnesium belong to the same period, that is second period. But if you see the groups, sodium belongs to the first group and magnesium belongs to the second group. On moving from left to right, first the ionization energy increases. Okay, and the sodium and magnesium is in first and second group, right? So, and it is given that from left to right, the ionization energy increases first. So, as it is present in the first and second group only, that means the ionization energy is increasing in these two elements cases. Okay, therefore, the ionization energy of magnesium is greater than the sodium. We can say this, right? Because in the periodic table, the sodium and magnesium are in first and second group respectively, and if you see along a period, the first ionization energy increases. Okay, so magnesium will be having the greater ionization energy as compared to the sodium, and that is what the generally observable trend in the first ionization energy along a period, and we have to find out which is not an exception. So that means we have to find out that along a period which two elements show the first ionization energy increasing along a period. So sodium and magnesium is the correct answer. Thus B option is the correct one. Okay. Now let's move to the next question. Question number 50. A sudden jump between the values of second and third ionization energy will be associated with the electronic configuration. So we have given some electronic configurations in the option, and we have to select the one configuration in which we can clearly see the jump or sudden jump between the values of second and third ionization energy. Options are 1s2, 2s2, 2p6, 3s1, 1s2, 2s2, 2p6, 3s2, 3p1, 1s2, 2s2, 2p6, 3s2, 3p6, or 1s2, 2s2, 2p6, 3s2. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The correct answer is option D, that is 1s2, 2s2, 2p6, 3s2. So, as the sudden jump in the ionization is observed between the ionization, second ionization energy and third ionization energy, as given in the question. Okay, it can happen when we have two valence electrons in our element. Okay, because if we having two valence electron, then first ionization energy will be of removing first electron, and then second ionization energy will be removing of second electron. But for the third ionization energy, we have to move to the previous orbital or previous subshell. So that will take a lot of ionization energy. So there is a jump between the second and the third ionization energy in that case when we having a two valence electrons. So the electronic configuration must be 1s2, 2s2, 2p6, 3s2, because you can see two valence electrons are present here. And if you see that first ionization energy will be of removing one electron from this 3s orbital, then second ionization energy will be of removing one electron from only this 3s1, and then we need the third ionization energy for removing the electron from 2p6. But 2p6 is a stable subshell, right? 2p6p is having the maximum filling electron as 6, right? So it is in stable form. But if we want to extract one electron from 2p6, we have to provide more and more energy, ionization energy. That's why you can see a sudden jump between the second ionization energy and the third ionization energy for the extracting of electrons, right? So this will be the correct electronic configuration for this concept, and thus option D is the correct answer. Okay, let's move to the next question. Question number 16. The first ionization potential of sodium, magnesium, and silicon are respectively 496, 737, and 786 kilojoule per mole. The ionization potential of aluminium will be closer to. So we have to find out the ionization potential of aluminium. We have given the first ionization potential of sodium, magnesium, and silicon values. Okay. Options are 760 kilojoule per mole, 575 kilojoule per mole, 801 kilojoule per mole, or 419 kilojoule per mole. You have 10 seconds to solve this question. After that, we will see the answer. Okay. Let's see. The correct answer is option B, 575 kilojoule per mole. So ionization potential increases from left to right, while in case of elements possessing fully filled or half-filled orbitals, their ionization potential is more as compared to the elements having unstable configuration. So if you see generally, the trend of ionization potential is it is increasing from left to right along a period in a periodic table. Okay, but in case of the elements having fully filled or half filled orbitals, like in the case of p, either p6 or p3, fully filled and half filled, their ionization potential, if we want to extract the electrons from p6 or p3, so ionization potential we need in that case is more as compared to the element having unstable configuration like p5, p4, p2. Okay, and since sodium, magnesium, aluminium, and silicon all belongs to the same period, thus the order of their ionization potential values would be this. If we know the concept of this, that it will be increasing from left to right. Okay, so order will be this. But magnesium possesses fully filled 3sp, 3s2 orbital. In the magnesium, you can see it is having 3s2 fully filled orbital. So its ionization potential value would be larger than that of aluminium. Okay, so the correct order would be this: highest for silicon, then magnesium, then aluminium, and then sodium. Hence, the ionization potential value of aluminium according to this order would lie between the sodium and magnesium. You can see right? Sodium we have given 496, magnesium we have given 737. So we just match the values from the options which lie between these two values, and it is 575. Thus, the ionization potential of aluminium should be 575 kilojoule per mole, and thus option B is the correct answer. Okay, thank you.